Hi, in this presentation, I'm going to be talking about Rust and Bevy, but mostly Bevy, from the perspective of someone who is working part-time, 20 hours a week, working on a game. This talk is going to cover a few elements, both more technical and more practical, but we'll get to that. So the perspective I'm coming to from here is sort of working on a large-scale game, working with artists, preferring open tooling, and being a Rust developer. That little robot on the side is sort of the mascot of my game, so I had to slip him in a few times. So this presentation is going to cover two areas. The first area is the technicals of Bevy and ECS. Now, this area is going to cover some code examples, and we're going to cover ECS, the entity component system, schedules, resources, and that sort of technological understanding you really need to master in order to create great games in Bevy. The second part of this presentation is going to be focused on practical elements. We're going to talk about how do you work with artists? How do you find assets? What challenges do you have? How do you pitch a game, if you're looking for investors, written in Bevy? A unique challenge. And so we're going to go through all of that, and by the end, you should have a practical understanding on how to write a game in Bevy, and also how to sort of approach the larger ecosystem using Bevy as a foundation. So, part one, the technicals of Rust and Bevy. So, what is Bevy? Bevy is a rapidly changing, community-oriented, code-first, data-driven, opinionated to open standards game engine. I'll get into each of these in a bit here. So, rapidly changing. This is something you must be aware of if you decide to write a game in Bevy. Bevy targets a new release every 3 to 6 months, depending on a few things. And we can have game-breaking or API-changing effects in those games, or in those releases. This also affects the sort of ecosystem of crates around Bevy. So if you are going to be writing a game in Bevy that's less of a sort of game jam and more of a big product, this is something you need to be aware of. And the way I personally handle this is I am rigorous about updating. As soon as all of my dependency crates are working with the next version of Bevy, I dedicate it the appropriate amount of time to get it updated. Well, community-oriented. Bevy is really cool in that it is an anarchist, organized PR and code structure. You don't need to be a core maintainer to sort of propose features and pitch and add bugs. As I was working on this game, or as I was working in Bevy, I found a bug in the KTX2 texture parsing logic. And I just, without talking to anyone, I just submitted a quick patch. And that's how I sort of entered into the Bevy sort of developer ecosystem. And it's really cool. There's a great talk from Rust Week talking about how Bevy works from an organizational perspective, but it's incredibly community-oriented. Like if you ever worked with Unreal or Unity, you gotta take what you get. But with Bevy, you can not just modify the source code, but you can coordinate with the community at large to help drive the direction that the game engine goes in. A unique advantage. Even compared to Godot or Godot, which is a huge project, also open source, and you can help drive it. But in my experience, a bit more difficult, just because there's so much sort of high stakes stakes owners there. So, Bevy is also unique in another way. It's code first, meaning that there's no scene editor at this point. There will be one coming soon. There's no sort of like preview mode. There's no anything special outside of what you would be doing with your text editor, maybe a language server processor, and Rust. So to me, I love that. I can just live in Neri, I can live in Sway, and I can work on my Bevy games. I don't need to worry about mucking around with different GUI applications, but just to be aware. And it is data-driven, meaning that when you are using Bevy, the sheer nature of ECS, which we'll explain in a bit, sort of says that this game is going to be driven by not the relationships between all the objects, but the actual sort of intrinsic properties of those objects themselves. And it is opinionated to open standards. Bevy aims to support more proprietary formats like FBX and things like that, but everything by default is open standards, WebP, we got your GLTF and our GLB. It's opens first with proprietaries added on as resources are available, which is very nice. So let's talk about ECS. I've spoken about ECS. I've mentioned ECS a few times. So ECS is very different compared to your traditional game development model. And this has massive advantages. There might be some disadvantages, but I don't see them. Now, this means you have to program Bevy in a different way. So if you have your traditional game development, you might have your sort of tree of nodes and your UIs here and your settings are here and your hierarchy of scenes are in there. This leads to a sort of system whereby you have to sort of interact and you have to sort of factor in those relationships when you are coding. In Bevy, you don't. Let's talk about ECS. Entities, components, and systems. Entities are the things in themselves that you spawn into the world. They are the scenes, the objects, things like that. Components are like tags that you tie onto those entities. With those components, you can do, say like, hey, this entity has the component manufactures units, and that component can have implementations and traits that are tied to that entity. But because there's no hierarchy, it's a very flat system, you can run a lot of stuff in parallel. So we'll talk a little bit about systems here as well. When you're looking in Bevy, you have your components, which are just your free-floating sort of objects, your entities, which are free-floating objects. You have your components, which are attached to those objects, or not attached, but they can be like sort of tied to, and there can be many objects with the same components. And you have your systems. Systems are what actually do the work. So systems are, like you can have them run every frame, or on startup, or on shutdown, or state change, or when a certain component changes, or a certain entity comes into existence, or despawns. So all of these things are sort of event-driven or frame-driven, depending on how you configure them. And we'll get into that a bit more here. So we have plugins. So Bevy is injection pattern all the way down. It's just infinite turtles of injection pattern. So when you're writing a game in Bevy, it's just going to be plugin. And we'll get into that a bit more. And your plugins hold your systems, which are in your application. I hope no one's too lost here at this point, right? Maybe? Okay. We'll explain more and we'll show some examples. So, before you actually get to writing any Bevy, top piece of advice, don't skip performance optimizations. Rust and Bevy used to have a reputation for like, oh, it's so slow, it takes forever to compile, even a little game. But if you go to the Bevy sort of learning page, you'll get your optimization. So if you are playing with Bevy, don't skip this. I'm going to call it mandatory, even though it says optional. Otherwise, you're going to have a bad time. So let's talk about the most basic possible Bevy application. And this is it. It's just main.rs. We have our application, our app, and we have the default plugins. The default plugins is a sort of recommended set of basic sort of structs and enums and state that Bevy provides for you. You don't have to use it all. People write terminal games. They don't use this. People write physics simulators. People write sort of 3D exploration applications. You don't necessarily have to use default plugins, but if you're learning Bevy, strong recommend, and this is where you start. So what happens if you just run this code? Wow, impressive. Actually, I'm going to say for a Rust application, like how many lines is this? Like 1, 2, 3, 4, 5, like 7 lines? 7 lines for a Rust application to get you an empty UI? I'm going to call that actually pretty impressive. I had played with QML in the past, and it would be what, like 150 lines? Quite nice. And a lot of that comes from the sort of default plugins, default resolution, default color, default everything. So let's expand upon this a little bit here. Let's add a setup. So we're adding a system. It's not in a plugin yet, because we're not there. But we're going to add a setup function. And all that this does is it runs on startup when the application launches, and it actually spawns a 2D camera, and it spawns a sprite. We're making progress. We're getting a real game. And what do we get when we do this? I chose GPN 11 just because it looked cool. I'm trying to figure out which one kind of works here. GPN 11, iconic. And now we have a sprite. We have something we can work with. Now, let's build a bit more on this. So if we have our sprite, we can do even more. So we have our setup from before, but now we have our rotate. So let's take a look here. If you look at line 19, it's a little cutoff here, you see I added something called rotating. If you look above, you'll see line 3 and 4, we have derived component, rotating. Rotating is a component with no data attached to it that lets you say hey, this is attached to any given amount of entities. In this case, as we're spawning in our sprite, we're attaching rotating. Now, what does that actually let us do? So we have on update, the schedule update you see, which runs every frame, we run rotate. So if we look into the signature, the function arguments of rotate, we'll see that we're running a query. So we're running a query, we're looking for the transform of anything with rotating, and that's the query, right? So anything with rotating, we're looking for the transform of it, or its location in absolute space. And we are also getting time as a resource. Time is something that you get. You can set up timers and stuff later on, but you just get a basic time resource as you set up the game. And what we're doing is that this is very C style. I would normally write this a little more functional, but in order to make it easier, we're going to keep it sort of C style. But for mute transform in our query, we are going to rotate it around Z based off of the time. So we're making progress. We'll see what we get from here. Wow, we have rotation. Now, you saw we got that for free. Not for free, but very close to free. Simply by adding that rotation tag. If we were to add 40 more sprites and we were to give them all that rotation tag, they would all rotate. And because that same rotate function is around the same sort of time, they would all rotate at the same rate in the same way at the same pace. You can do a lot more with that, but I wanted to try to keep the code a little more concise here. So we can actually even go a little fancier. So we have here, can I change this right? Rotating resources. This might be a duplicate slide. Let's see here. So, I went back to go explain. When I was writing this presentation, I meant for myself to go forward. So don't overthink things when you're writing these slide decks. So we talked a little bit, sorry this is small, if you go into the Bevy docs you can see more. We talked a little bit about those schedules, and we're going to talk a little bit in the future about conditions. Schedules are how you sort of determine when your systems run. Update is every frame. Startup is the startup of the application. Last is last. Pre-startup, post-startup, first. There's way more than these. These are just some of the basic ones. And you can see we've already explored 80% of the structure of Bevy. ECS makes it so you can do so much with just a few sort of basic components. And we got our conditions here. So you don't always have to run everything on every frame. You can say, hey, this runs every frame if this resource exists. This thing runs every frame, but only when a resource is removed. This runs every frame when we have any element with a component, if you think about that. So you can say, hey, we only want to run this rotating system if we have entities with rotation. And we can do that and get a lot of performance. We don't have to do if this, then this, return in all of our functions. We can write elegant, clean code just by using systems and conditions. Side note, I don't recommend using LOMs at all. We'll get into this later. But they will write the most ugly ugly code you've ever seen, because they don't know anything about this and they don't like it. Don't use LOMs, especially on sort of structuring the code of your Bevy games. Pro tip. So, okay, we're getting more code. I tried to keep it as concise as possible. The original version of this deck was even smaller, but I broke it down into 2 separate ones here. So, we have our startup setup, just like we had before. We had our rotate, but this time, run if in state, game state playing. We'll get to that in a bit. We have on enter game state playing, and we have a bunch more, but we'll get there. So what is game state? Game state is an enum. Okay, we got that part. But game states in Bevy let us enums in Bevy let us turn that into state. You can have here a state which says like, hey, the representation of this enum defines elements in the game. We can have the enum be main menu, pause, game running, settings, or whatever. And you can use these enums, these states, to control the flow of your code. I think we're getting close to 100% of all the stuff in Bevy now. And that lets us do so much in a sort of beautiful, non-twisted spaghetti code without referencing a huge hierarchy of trees, just a flat ECS clean system. So, like if we say here, if you look at line, there used to be highlighting, so I somehow lost it during my deck template. So if we look at like on enter, game state playing. So when the game state becomes playing, this runs once. You don't have to worry about it. No ifs, thens, theirs, or anything like that. We have so the update for the rotate. It only runs if we're in game state playing. We don't need to run a system on every frame if we're in the menu. This lets us do a ton in such a way where everything is extremely scoped and limited. You don't have to worry about you're running 14,000 things on every single update. You just say, hey, this runs on update, but only if there's something on the screen that needs it. Brilliant, I think. So we can talk about a little bit more here. We have this toggle state, which does run on every frame. What does it do? We have our keyboard resource, our state itself, our next state, which is we're accessing mutable because we might be changing it, and we are going to process it here. So keyboard, just press, key code space. We're going to match the state. We're using some of that Rust niceness, and we're going to say if we are getting in menu, we're going to set the next name to playing, and if we're in playing, we're going to go back to menu. So this lets us use Rust, those native Rust elements, to write a game. We're not just abstracting over sort of an object-oriented system from another engine. It's Rust native. It's Rust first and Rust focused. A few notes I will say: if you're actually writing a game, I don't recommend you access the keyboard in this raw way. It's going to be incredibly difficult to add remapping. Ask me how I know. So we'll get there. So let's talk. Let's see, what does this actually lead to here? So, did I change something here? We're changing the color. But this here. Oh yeah, I missed the function. Did anybody catch that before I noticed? Anybody's like, did they miss something? Yeah. But on enter playing, we changed the color. So the first time, if you look at the system, on enter playing, on enter game state playing, we set for mute sprite in mute query, sprite color is red. So if you look at the actual signature here, we'll say we have the query itself, and that's it. We don't have to worry about it. We don't have to search a node of trees. We just tag what we want to change with a component, and then we write a function that acts on it. It's kind of SQL-like, kind of beautiful. Very beautiful, I would say. So what can we do here? It lets us sort of do these queries. So if you're wondering, hey, if we look at on enter playing, where did those sort of arguments come from? Bevy provides, you can access query, you can access resources, you can access components. There's a bunch of things that you can access, and then Bevy will automatically give you what you need depending on what you access. So you don't need to worry too much about that. Bevy docs really talk about what you can sort of access in your systems, but it's a lot. So yeah, back to this. The color red is from the first time we play it. Here we go, starting again. Red and rotation, and we can pause the rotation because the rotation only runs when we're playing. When we're setting it to menu, it's not working. automatic. It's pretty elegant, I would say. So let's talk even a bit more here. Oh man, I really wish I had my code highlighting here. So we have our rotate and play, toggle state. Yes, I think I was doing the same thing again where I was talking about it again. So let's talk about how do we organize this? Like, if we step back here, oh my God, I did it again. If we step back here, we'll see. Like, if you have a complicated game, if you're writing Factorio, good God, you're gonna have a lot of systems. So you got to organize this somehow. I mentioned at the beginning that Bevy is injection pattern, plugins, turtles on turtles all the way down. So we're going to talk about how we actually organize those. We do it via plugins. We have our demo plugin. In that way, we can have just our our main nice and clean. Everything is segmented and organized. So we'll talk about that structure again. We have our entity. Now that I've explained a lot, we have our entities, the things that you spawn into the world, our components, those things that you tag them with, and then plugins, which we'll cover here in a bit, that sort of contain and organize them so you don't have a huge 10,000 line file, bunch of systems. So let's talk about that then. So here is a realistic app. This is actually from my game I'm working on. So we have our main, you can see up there at the very top, we have our game state, which is splash screen, menu, and game. And splash screen, I'm sort of loading some assets really quickly for the main menu. The main menu is where you sort of launch the game or configure things in the game itself. So we have our plugins. We have our embedded assets plugin, we have our default plugin, we have our tweeting, we have our input dispatcher plugins, we have our directional navigation plugins. Very important for accessibility, by the way. Strong recommend when you're writing a game in Bevy, or any game at all, when you're writing any software at all, please consider accessibility, like things like screenwriters. Like there's a great crates out there, like A Ally, which is A11Y. Please do it. Please prioritize it. Makes life for a lot of people much better. We have our physics engine. I've switched physics engines since then. Our game state, and we have here just 3 plugins here for the default build. We have our splash screen plugin, menu plugin, and game plugin. And you can see down here where you have this debug assertion, we add our debug rendering stuff so I can see all the grids and things only running in debug mode. So let's continue on here. So this is how you actually write plugins. We've switched from trivial sample code to real, more production code. We're implementing a plugin for building management. We're building it, so we have our self and our application. Or adding some resources, which I define elsewhere, which are those sort of resources are different than entities and components in that they are sort of permanent things that all systems can access. Great use of resources might be internationalization or certain usernames, things like that, things that aren't going to change, that you can read anywhere. And you can sort of not have to worry about in terms of tagging and things like that. And we have our systems on enter. When the game on enter, loading tracker loaded, we populate building assets. So I didn't have to schedule how things are loaded or when things are loaded. It's just like, hey, when this is done, we start doing this. And we have our updates where we update our buildings and cycles, and we add all of this. And here, you'll see something very interesting at the end. We add a building UI plugin. So we have this plugin implementation, which in itself calls a smaller plugin. Building management has building UIs inside. So as we can see, we're building sort of plugins all the way down. But there's no hierarchy in that sense. Like the building UI plugin isn't scoped in any sense to building management. You just use those same ECS queries just like you would for building management or any other plugin. So let's look at a more realistic system now. We did some of those trivial rotation things. We did some of those color changing systems. But this is a system which sort of updates the production of a building in a factory game. So we have our cycle complete system. Ooh, a small note. This screenshot was from an older version of Bevy. So if you're using the latest version, events will look slightly different, just FYI. And we have a basic query. So we have for the entity itself, and then we have the building, which we've queried for, and the cycle, which we've queried for. We're going to query it, iter mute. So if the building doesn't have a cycle, we just continue, because like if you have a power pole, it doesn't have a cycle. You just get past that. And update our timer here. So we're going to tick the timers on the buildings, and we are going to write events when buildings complete those cycles. And other systems will handle those events and actually go and produce the iron plate onto the belt. So we have that. Pretty cool. Again, this is written in a more C functional style, or a C sort of a C style. Strong recommend for using maps and things where you can. But you can do it this way. Both are valid. So let's talk about learning Bevy. Bevy.org, quick start, great starting point. It doesn't take you very far, but it'll get you started. The main way I recommend learning Bevy is by using the official Bevy examples. They have the Bevy code and a running they have a running version in the browser, so you can play with the game and then look at the code at the same time and sort of see how they interact. There are two sort of third-party resources, Tainted Coders and Bevy Cheatbook, also excellent, but not always up to date. So both of them say hey, this documentation was based off Bevy 0.14 or 0.16. Right now we're on 0.18. So be a little aware. So you can use those, but be aware. Don't learn Bevy via LLMs. Don't ask LLMs questions to learn Bevy. I'm not saying there's no use for LLMs, but it's terrible for Bevy and probably terrible for most things. Just because, one, LLMs have very old training data, so if you do tell an LLM to write Bevy code, it'll spit out something from Bevy 0.4 in the 2016 release. So just be aware. Don't learn from LLMs. Now, here's an example of those of that site. You can see here we're playing a little game, and beneath it you can see the beginning of the source code. Strong recommend. Read the tutorials as far as you can, and then anytime you want to add a feature, go find the example. There's hundreds of examples. This is a more complete example, but there's examples that just focus on spawning things or running things or doing things. So let's talk practicals. We've covered the sort of technological foundation of running a game, writing a game in Bevy, but if you're a game dev or you're sort of working on a game outside of a sort of a small project, you're going to run into a lot of stuff here. So rapid progress equals frequent changes, meaning that once every 3 months, I need to take a week out, or maybe sometimes a little less, depending on how big the changes are, to update my version of Bevy. That means once in a while, I say, oh, this crate I was using, it hasn't been updated. I need to consider dropping it or not. But the upside of that is rapid progress. Every version of Bevy is better than the last. I've actually gotten burnt by this a few times where I'm like, hey, I'm going to implement this great feature I'm going to use, and then I find out that there's a better version of it included in the core game 2 releases later. So rapid progress is a good thing. It's not bad. So other thing, WebGPU and WGSL shaders. I know for me, this was a sort of struggle. I'm pretty decent now, but I had to learn how to write WGSL shaders, and I had to learn how to do so with not as much tooling as I would like. Bevy has a dialect of WGSL, whereby you can sort of import your data structures from Bevy and use them inside of WGSL, and that makes it a little complicated to use more standard tooling. But if you strip out the Bevy-specific stuff, standard tooling for analysis works fine. And another thing is, when you're working with people and you're trying to organize a team, or not so much in a game jam nowadays, but if you're working with people in a more professional context, you're going to get a lot of WTF is Bevy. Why are you using Bevy? Let's just use freaking Unreal or whatever, but or Godot maybe. They might say, okay, maybe Godot, but it's a big factor. It's a realistic factor. But personally, when I work and when people I work with work on things, we're driven by passion, and for me that means working on Rust. I'd rather work on an obscure Rust library than then an incredibly robust Java enterprise factory builder factory, sort of setup. So, Bevy difficulty. Rapid progress equals frequent changes. That's a difficulty, I will say. But rapid progress is worth it. Open standards. You think GLTF and GLB would be well known and well supported, but when you're working with artists, they often don't know about these formats very well. They don't know about like YUp or things like that. They're thinking in more traditional like Unity or Unreal thought processes. So there's a little bit of onboarding time when it comes to working with artists. Now, this is a big one. It's hard to collaborate with non-devs. When I was working on my game, I had a situation where I'm like, hey, the lighting looks really bad. Like, I'm not a color person. Like, I'm not a lighting person. The shadows look bad. And the artist I was working with was like, oh, I got you. I work with that all the time. We're going to do like tone mapping. We're going to apply this profile. We're going to use this. And really, I'm like, great. Here's a Git link. And they had never used Git. They had never compiled anything. They had never used Rust. They had no dev tools at all installed on their computer. And it was a problem. And what I ended up making was I ended up making a sort of micro version of the game whereby they could edit a toml file and change a bunch of settings and relaunch it. They still were extremely unhappy with that, but it worked. It's a real Bevy difficulty. Getting better. So Bevy is making progress. There is a scene editor and a sort of UI that's coming here soon that's going to be a sort of inclusive of the existing work. But it's getting better. Not there yet, though. And WTF is Bevy factor. Again, a difficulty. Let's talk about Bevy easy wins. Rapid progress is frequent changes. Those features that you want are going to get there. If you submit a PR or an architecture change, or if you need something and you submit it as an issue and people start working on it, you'll get that upstream 2 months, 3 months, maybe 6 months if you're unlucky. It's excellent if you need something and you want to have it. It's amazing for data-heavy games. The first choice I made for the factory game I'm working on is to use ECS. And then I sort of trickled down what engine should I use. I chose Bevy because it's excellent for data-heavy games. Remember all those systems we were talking about earlier? We can have those run in parallel. They run in parallel by default. So if you have all these systems and you have them set up so they're not chained together where they don't have an explicit order, you can use like 24 CPU computer and your game will just be multi-threaded, multi-process by default, just because of the sort of ECS native architecture wins. So big advantages there. We have a top-tier community. Amazing. Like, I started Bevy as a user. Now I'm contributing a few packages and I'm getting mostly around asset loading stuff. But just because I saw these little pain points for me, I was able to start working on PRs, and now I'm contributing on a semi-regular basis. Another great win is easy binary releases. You can release a single ELF file, that is your entire game, or a single .exe, that's your entire game. You can, unfortunately, I've tried very, very hard, but you can't actually create a muscle build. I tried, couldn't do it. Reason being is that you need some Wayland libraries, which you can't include in muscle without making the whole kernel muscle, and it's a pain. But easy binary releases, it's excellent. And you get all the benefits of Rust. You have cargo, you have the tooling, you have the crates, you have the ecosystem. All those Rust packages and libraries that you use, you get them with your Bevy project. There's no compromises. So, I'll say this. Should you use Bevy? If you're passionate about Rust, absolutely. If you like frequent updates and you like to see, if you do like DNF or apt or Pac-Man update and you get excited, you should use Bevy. If you write code first, you're a code first game dev, you should use Bevy. And if you're just a general cool person, probably should use Bevy. Now, if you're concerned with risk, or you prefer GUI tooling, or you just don't like Rust, you probably shouldn't use Bevy. But yeah, I personally use Bevy, and I recommend it. Thank you very much, and I'm happy to answer any questions that people might have.
Yeah, thank you very much, Caitlin, for this really lovely talk. I learned a lot of things as well, and I hope you did as well. So if there are any questions out there here in the audience, feel free to ask, and we'll pass on the mic, and then you can ask right away. Yeah.
Hi, thanks for the talk. One question maybe for this easy binary production. So how cross-platform is this? Is it like cross-platform like for free, or there are some things that you have to, some workarounds for Linux and for Windows and for all those builds?
I would say cross-platform for free. I release Windows, Linux. I release RISC-V binaries. I release ARM binaries. I played around with FreeBSD binaries. I compiled them, but I don't actually know if they work because I don't have a FreeBSD system. But just think of the Rust targets as the Bevy targets. Anybody else? Yeah.
So I see you have your own game there, Exafactory, right?
Yeah.
Are you aware of other projects that use Bevy for like?
Yes.
The community?
Yes. tinyglaive, excellent project, uses Bevy. Absolutely beautiful. It's the whole interface, the whole user experience is written in shaders. Stunning game. But if you do want to learn about more Bevy projects, if you go to the Bevy Discord group and you look at the projects or just the oh my God, can't remember the channel, but there's a channel that people are showing off the games that they're working on. You'll see a lot more. But yeah, tinyglaives is an excellent release project. There's other games on Steam and mine as well. But yeah. Anything else? Any other questions?
What about networking in Bevy? Is there something built in?
So there are two well-maintained, well-used libraries for networking in Bevy. One is Replicon, and we can talk about that. We can talk about how does ECS work on when you add like multi-client systems. And the other one is Layer. We'll talk about the two. Replicon is a system that's all you do is you say, hey, things with this component are replicated from the server instance to the, you just add a replicated component, and then the client that connects to it just gets it. And there's well-supported, like the networking stuff, there's several well-supported networking libraries from anything from like HTTP quick to UDP or TCP, or there's priority, there's libraries that support like priority queues and even things like rollback, very cool. But yeah, it's all available via well-supported crates in the ecosystem. And we can talk about multiplayer a little bit. I should probably add this as a deck. But yeah, because you have ECS, it's very simple to replicate components across server to client if you have a sort of a server authoritative game. And because of ECS, I have all this sort of breakout, you can create a headless version of the game for very low cost. It's just a bunch of config feature gates, and you say feature headless, and the actual entity component core can run, and then via messages and things like that, you can sort of interact with the world. The server changes the components on entities, and then those get replicated out. So that is sort of Replicon. There's also Lightyear, which is another very well-supported networking library, and that has all of the fundamental concepts that Replicon does, but it also has things like rollback. It has rollback. It has client state management. You can do even like control-based game management where the client's controls are just passed in. It does prediction, and if you're writing a first-person shooter or any game that's twitchy at all, you probably should use Lightyear. But if you're writing your first Bevy game or your game isn't twitchy, I recommend Replicon just because it's much easier to set up. From nothing to having the client connect to getting components synced, it took me like 2 hours. but it took me like a week to debug. So, take that as, with a grain of salt there, yeah. Anything else? I think that's a no, but I'll say, actually there might be more, but I will say later this afternoon there's a workshop. I think it is full, but all of the workshop information and this presentation I will add a link to the presentation description where you can see all the source code I gave here, and you can get a copy of this deck itself. And for the workshop later this afternoon, the workshop will be self-guided, so even if you're not there, you can sort of work on it on your own, and it teaches you how to use Bevy and sort of start from a very basic game and expanding into something more of yours. And it's also very, very GPN themed. Yes.
Okay, thank you very much, Caitlin, and have fun trying out Bevy, and give a really, really warm applause for her.